Okay, in the last section, 4.4, we concentrated on adding and subtracting polynomials, and we also learned some basics of polynomials, how to identify terms, the degree of each term, and so on. Okay, so now we're going to get into multiplying polynomials. Alright, so this section, 4.5, is on multiplying polynomials. Alright, so recall way back when we first started the semester, section 1.6, where we learned some properties. Remember the commutative property and the associative property and so on, and that was over addition and multiplication. So we also talked about the distributive property. And remember, as all that was, if I just take A times B plus C, remember I multiply A times B, and I get AB, and this is over addition, so plus, and then A times C. That's AC. So this would work the same way, the distributive property over subtraction. Okay? So that's just A times B is AB, A times C is AC, and this is over subtraction, so you subtract. Okay? So we'll do a little bit of different variations of the distributive property, but it's basically all the same. Okay? So let's start out with multiplying two monomials. Okay? Now one thing, let me write down some terminology that I'm going to be talking about. So before we start multiplying, let's just talk about a monomial. And what that is just a single term polynomial. Okay? So you might have, 2x squared, or you might have minus 3x, or you might just have a constant 5. Okay, these are all considered polynomials, so this is a polynomial, this is a polynomial, and this is a polynomial, but a specific name, because there's only one term, it's a monomial. Alright? So guess what a binomial would be? Okay? Well, if a monomial is a single term, then a binomial has two terms. So it's has two terms. Okay? Two terms. So for example, like 2x plus 1. 5x to the fourth minus 3. X squared plus x. Okay? Notice here, two terms, hence called a binomial, but these are also called polynomials. Okay? A polynomial is just a general term for multi-terms. It could be one term, two terms, three terms, so on. Okay? But specifically, since these are two terms, it can be called a binomial. And guess what? We can say trinomial. So how many terms do you think that would be? Well, tri being 3. So I could have 3x squared minus 2x plus 1, 7x cubed plus x minus 5, 2x squared minus 5x plus 4. Okay, so basically 3 terms, trinomial, and again, what could we call this in general? We can also call it a polynomial. Okay? After trinomial, there's no specific name. You would actually just call it a polynomial. So for 4 terms, 5 terms, and so on. No specific name, just polynomial. Okay? Excuse me. So with that said, when you hear me mention these names, a monomial, binomial, I might say multiplying two binomials together, or a monomial times a monomial, you'll know what I'm talking about. All right? So, let's look at multiplying monomials. All right? And this is where we're really going to use the law of exponents that you previously learned in the last couple sections. Okay? So we're going to apply the law of exponents. All right? So let's take this monomial. Let's say 3x squared times a minus 4x. Okay? And as all you do is you're going to multiply the constant terms, or the coefficient terms together. I should say coefficient terms, which are these. So 3 times minus 4 is a negative 12, and then x squared times x. So remember, when you multiply variables with the same base, you add the exponents. Remember, there's like a little 1 there on the x, so 2 plus 1 is 3. So this would be x cubed. Okay? How about this? 9x squared y to the 4th. So here's a multivariable monomial, and then 8x y to the 5th. Okay? So again, let's multiply the coefficients. So the 9 and the 8, that gives us 72. And then let's multiply the x's together. So x squared times x is x cubed. And then y to the 4th times y to the 5th. Add 4 plus 5, you get y to the 9th. Okay, so your answer is 72 x cubed y to the 9th. All right? Okay, let's look at another multivariable. Let's say we have 15 x to the 6th y squared times 2y to the 8th power. Okay. Well, again, let's multiply the coefficients. So 15 times 2 is 30. All right. Now, there is no x term where there's 2y to the 8th, right? So you just leave it alone. So you still have x to the 6th. It doesn't disappear. You still have it. Okay? All right. And then y squared times y to the 8th is y to the 10th. 2 plus 8 is 10. Okay? So that's how you multiply monomials. Now, if you notice, I just multiplied 2 monomials. What if I had 3 monomials? So let's say I had 3x cubed times 4x times a negative 5x squared. Let's say I had 3. Okay? 3 monomials. Well, just like you would multiply, let's just use the coefficients, 3 times 4 times a negative 5. I mean, how would you do that? Well, you'd go 3 times 4 first, and you'd get 12, and then that's times negative 5, and 12 times negative 5 is negative 60. Okay? And that's how you're going to approach this. You do the first 2, okay, get that answer, so let's do that. So 3 times 4 is 12, and then x cubed times x is x to the 4th power, right? Don't forget that little 1 there. So 3 plus 1 is 4, okay? And then you just bring this down. Okay, so that's going to be times negative 5x squared. Okay, so 12 times negative 5, okay, is going to be a negative 60. And then x to the 4th times x squared is x to the 6th. Okay? All right, so that's multiplying monomials together. What if I take a monomial times, let's just call it a polynomial. Could be 2 terms, 3 terms, 4 terms, whatever. Okay, so it could be a monomial times a binomial, a monomial times a trinomial, or just a monomial times a polynomial in general. Okay, so let's go a monomial multiplied by a polynomial. Okay, so let's say 2, or let's do this. Let's do minus 5a squared b, okay, minus 5a squared b, times 2a squared minus 3ab. So notice we have a multivariable monomial, and then we actually have a binomial here, right? This is a binomial. Okay, so guess what? We're going to use the distributive law. So I'm just going to take this term times this term, and then the monomial term times this last term. Okay, so let's do that. So this equals negative 5 times 2 is negative 10. A squared times a squared is a to the 4th. Okay, and there is no b, right, on the first term of the binomial, so we just keep the b there. We don't do anything with it. All right. Now it's negative 5 times negative 3, so that's plus 15. Okay. Then a squared times a is a cubed, and then b times b is b squared. All right. And then that would be the final result. Okay. So the final result could be called a multivariable polynomial. It also could be called a multivariable binomial, right? Okay, let's look at a monomial. Let's say 7x squared times 8x squared minus 3x plus 4. So we actually have a monomial times a trinomial, all right? Or again, we could also call that a polynomial. So this is just a specific name for these three terms here. Okay, so very simple. This times this, this times this, this times this. Distributive law, right? So I'll just do it right here. Equals, so 7 times 8 is going to be 56. And then x squared times x squared is x to the 4th. And then 7 times negative 3 is negative 21. X squared times x is x cubed. And then 7x squared times 4 is 28x squared. Okay? Let's do a quick review on this. Let's look at this term. What's the coefficient? It's 56. What's the degree of this term? It's a 4th degree, right? Let's look at this term. What's the coefficient? It's negative 21. What's the degree of the term? X cubed. Okay. And let's look at the coefficient here. It's 28. And what's the degree of this term? It's a 2nd degree term. And what is the overall degree of this polynomial? Well, since it's the highest degree is 4th, this is a 4th degree polynomial. Okay? So the terms are 56x to the 4th. The other term is negative 21x cubed. The last term is 28x squared. And again, the coefficients 56, negative 21, 28. The degree of each term, 4, 3, and 2. And the overall degree of the polynomial is 4th degree. Okay. Now, let's look at something that gets a little bit more complicated, but not much. Let's multiply two binomials. So, multiplying two binomials. Alright? So, again, we're going to use the distributive law. Okay? And there's a specific name for this for when you multiply two binomials. Okay? we can use what's called FOIL. You might have heard this before, FOIL. And this just means the first, the outside, the inside, and then the last. Okay? So first term, outside terms, inside terms, and the last terms. Okay? Again, it's just the distributive law. It's just a specific name for multiplying two binomials. So let's take a look at 3x minus 2 times 4x plus 5. All right? Now, let's go through this slowly. So we're going to multiply the first term, so the first with the first. Okay? So that equals 12x squared. Okay? Then we're going to excuse me, multiply the outside terms. Okay? So the outside would be these two are considered the outside. All right? So that is going to be plus 15x. Okay? And then the inside, all right, so the inside will be these two. They're the inside. Okay? So that's going to be a negative 8x. And then the last are going to be these two. Okay? So that's a negative 10. All right? Now notice we can combine these two terms together. Always combine like terms. So this equals 12x squared plus 7x minus 10. All right? So let's go back over this. This was the first. This was the outside. This was the inside. And this one is the last. Okay? Again, it's distributive law. Look what we're distributing. Let me go with colors. So I take the 3x times the 4x, right? Then I take the 3x times the 5. Okay? So I'm done with that. I've taken the first term and multiplied it by both terms of terms in that second polynomial there, right? And then I take the second term right here and then multiply it by the 4x and then the 5. So if I just, forget this FOIL thing here and just say, all right, well, I'm just going to use the distributive law. Well, it's this times this. That's 12x squared. This times this is 15x. This times this, minus 8x. And this times this, negative 10. Okay? And then, of course, you get 12x squared plus 7x minus 10. All right? Okay, let's do another example. All right? So let's say we have a multivariable one. So let's look at 3x squared y minus z times 8x squared y minus 1. Okay? All right. So however you want to look at this, FOIL or distributive law, we're going to multiply this times this. So that's going to be 3 times 8 is 24. Then x squared times x squared is x to the 4th. And then y times y is y squared. Okay? So that was first. And then outside. So that's 3x squared y times negative 1. So that's just minus 3x squared y. All right? So notice now we took the first term of the binomial and multiply it by both terms of this second binomial there, right? So now I move on. I take the second term of my first binomial. Okay? So we did the f and the o and then we're going to go inside, so it's the first term times this first term here. So a negative z, well, there's no z in the 8x squared y, so we would just write this as, and it's like a negative 1z, so negative 1 times 8 is negative 8, right? So negative 8, and then we have x squared y, and then don't forget the z, okay? And then we have negative z times negative 1. Well, negative times negative is a positive, and z times 1 is just z. Okay? Now, if we look at this, are there any like terms that we can combine? Remember, like terms are same variable, same exponent. And no, there isn't. So in this case, there's no like terms, so we're done. We don't add them together. All right? Now let me give you a little insight here. Let's just look at two binomials again. Let's say I have 3x plus 1 times minus 2x plus 5. Okay? Notice that the first term is like and the first term is like. The second term is like and the second term is like. So that means we will be able to combine like terms. So if I did this really quick, that would be negative 6x squared plus 15x minus 2x plus 5. Okay? So I go this times this, this times this, this times this, and this times this. Okay? But the key thing I wanted to show you here is, look, these combine. All right? So that equals minus 6x squared plus 13x plus 5. All right? That only works because the first two terms were like and the second two terms were like. All right? Let's do the opposite here. Let's just say I have 3x plus 1 times x squared minus 2. Well, these are like, right? But these two are not like. So we won't be able to combine any like terms. That's just a little insight. So let's do this really quick. This is going to be 3x cubed minus 6x plus x squared minus 2. And if you look at all of these, there's no like terms. So we're done. That is the answer right here. And notice again, remember we talked about writing our answers in descending order. Notice that we have a third degree, a first degree, a second degree, and then a 0 degree right here, 0 degree. So we should rearrange, excuse me, we should rearrange this. So we have the 3x cubed is good where it's at, but let's put the x squared in the second place. All right? So that's x squared. Let me get rid of this here. There we go. So plus x squared, and then first degree minus 6x, and then our 0 degree, which is, whoops, negative 2. So subtract 2. All right? So this is actually the best way to write your answer in descending order. Okay? I might have missed that, you know, up here. Let's see if I did. This is 6th degree. This is 3rd degree. This is actually a 4th degree here, 4th. So I really didn't write this in descending order. So let me change that. And, you know, sometimes you don't think about it and you miss it, but it's just a good habit to get into. So if I just erase this and I wanted to put this in descending order, it would be, do it in red. So this is 24x to the 4th y squared minus 8x squared yz minus 3x squared y, and then plus z. Okay? So that's written in descending order. I mean, this isn't wrong the way I had it. It's just a common practice in mathematics to express your polynomials in descending order. Okay. All right. Now let's take a look at this problem. So this may throw you off a little bit. So what if I have a monomial times a binomial times another binomial. Okay, in fact, this is a multivariable binomial, the last one here, right? Because there's an x and y in it. So remember, we kind of did a problem like this when we multiplied three monomials together. So I'm just going to multiply these first, get my answer, okay, and then multiply that answer. All right, so I'll multiply that answer, then times this one right here. Okay? So let's go ahead and do that. 4x times 3x is 12x squared. And then 4x times negative y is a minus 4xy, right? So I'll just put parentheses around that. And then here I just rewrite 3x squared plus 2xy. So we actually have two binomials multiplied together, so we can use FOIL or, again, just the distributive law. So this times this is going to be 36x to the fourth. 12 times 3 is 36. X squared times x squared is x to the fourth. Then 12x squared times 2xy, so that's plus 24, whoops, plus 24 x squared times x is x cubed, and then we have that y still there, all right? Then the inside, so it's minus 4 times 3 is minus 12, and then x times x squared is x cubed, and then we still have our y, all right? And then minus 4xy times our last term, so that's the L in the FOIL for last. So that's going to be minus 8. Negative 4 times 2 is negative 8. X times x is x squared. And then y times y is y squared. Okay? And I think that's going to be it, right? Now, one thing I want you to notice, that we have like term and like term, and we have like term and like term. So we know we'll be able to combine like terms, and they're these two right here. So let's do that. That's going to be 36x to the fourth, and then 24 minus 12 is going to be 12, and that's x cubed y, and then minus 8x squared y squared. So we're not quite done. If we want to be, well, actually we are done. Because this is a fourth degree term, 3 plus 1 is 4, this is a fourth degree term, and 2 plus 2 is 4, this is a fourth degree term. So there's really no specific way that we have to organize these. Okay? So I'm just going to leave that as is. All right? Okay. Now, let's go ahead and look at just some different types of multiplication that we haven't done. So let's do a trinomial times a trinomial. We haven't done that, right? So let's say we have w squared plus w minus 9 times w squared minus w plus 3. Okay? So here, there's no specific rule except just the distributive law. All right? So this times this, let's do it. W to the fourth. See how you really have to know your law of exponents. This times this, w squared times a negative w is minus w cubed. And then this times this is going to be w squared times 3, so that's 3w squared. Okay? And we start all over again. This times this, w times w squared is w cubed. And this times this, w times minus w is minus w squared. And then this times this, w times 3 is 3w. Okay? Then finally, we have a minus 9 times w. So that's minus 9w squared. Whoops, it was minus 9 times w squared, not w. So minus 9w squared. And then minus 9 times minus w is plus 9w. Okay? And then minus 9 times 3 is minus 27. So if I haven't made any mistakes, let's see if we can collect some like terms. Well, there is no w to the fourth term, so w to the fourth. Okay, so I'm going to cross it out because I'm done with it. Now let's look for w cubes. Here's a w cubed, here's a w cubed, and that's it. It looks like a negative w cubed and a plus w cubed. They actually just cancel out. Okay, and then let's look at w squared. So we have a 3w squared and a minus 9w squared. So that's going to be a minus 6w squared. So now I'm done with those. Whoops, forgot one right here. Alright, so that's actually going to be, so if the 3 in the minus 9 is minus 6, and there's a minus 1 there, so it'd be minus 7, right? So be careful of that. Sometimes you see so many of these terms, so I'm done with that one now. So let's just double check. 3w squared, whoops, 3w squared minus w squared would be 2w squared, and 2w squared minus 9w squared is minus 7w squared. Okay, so I'm confident about that. Then we have a plus 3w plus 9w is plus 12w, so I'm good with that. And then we're going to subtract 27. This is our last term right there, so minus 27. Okay, so we end up with a fourth degree polynomial. There's 4 terms, so the answer is w to the fourth minus 7w squared plus 12w minus 27. Okay, and let's do this example here. So let's say I have a box, all right, and it looks like this. Okay, so here's our box, right? And let's put some dimensions. Let's say the width is 2x. Let's say the height is x plus 1. And let's say the length is 3x minus 1. And I want you to find a polynomial that represents the volume of the box, right? Well, we know that a volume of any box is the length times the width times the height. Okay? So just put in what we know. So the length, 3x minus 1, the width, 2x, and the height, x plus 1. Now, did you have to label L as 3x minus 1? No, you could have put 2x as the length and 3x minus 1 is the width. Those are all interchangeable, but just consistent, like I said, this is length, this is width, this is height. All right? Just by looking at the physical picture of the box. Okay, so again, it's kind of like we've done before. Let's just multiply these two together first. All right, so that's going to be 3x times 2x is 6x squared. So is that times that. And then minus 1 times 2x is a minus 2x. So now I still have to multiply by x plus 1. Okay. All right. So now 6x squared times x is going to be 6x cubed. And then 6x squared times 1 is going to be 6x squared. And then minus 2x times x is a minus 2x squared. And then minus 2x times 1 is a minus 2x. I can combine like terms. So this is going to be 6x cubed plus 4x squared, right? 6 minus 2 is 4, so 4x squared, and then subtract 2x. All right? So this actually represents a polynomial for the volume of that box. Okay? So that's all for multiplying polynomials. In the next section, in 4.6, all right, we're going to learn more about multiplying polynomials, but there are going to be some special products. So some special cases we're going to learn. Okay? So you really need to understand how to use the distributive law and FOIL and about multiplying monomials and binomials with binomials and so on and so forth before you can really understand the next section. Okay? Hope you guys are doing well and taking care of yourselves. Alright? Bye-bye.